Welcome to another edition of Brain Maths. On today's edition, we want to look at how to evaluate logarithm question without using calculator or tables, and how to arrive at a final answer. But before we proceed to solving these problems, don't forget to subscribe to this channel if you are just joining us for the first time, and turn on the notification so that you will be among the first to be notified when we release a new video. Coming back to the question on the board, we are asked to evaluate the following without using tables or calculator. How do we solve these problems? Without using calculator, without using any mathematical table. The first question says, the logarithm in base 2 of 16. We are given logarithm in base 2 of 16. The first thing you will do is to equate this to any variable, any alphabet of your choice. For this, let's start by saying equals to y. Logarithm in base 2 of 16 equals to y. If you look closely now, it looks like what we have done in the past. This resembles a logarithmic expression. And any logarithmic expression, without wasting our time, we can turn it into an index form. So we take this to an index form, and that will lead us to 16 equals the base 2 raised to power y. This 2 raised to power y is already in index form. How do we now turn 16 to another index form? In the same base as this 2. So 16 can be written as 2 raised to power 4, which is equals to 2 raised to power y. 2 raised to power 4 is equal to 2 raised to power y. And if you look at the two, they have the same base. So we can eliminate their bases, and we are left with 4 equals to y, which at the same time means y equals to 4. It's as simple as what we have seen on the board. The second question says, logarithm in base 0.5 equals of 1 over 64. Like I said earlier, you can equate it to any variable of your choice. Let's equate this to x equals to x. And then let's rewrite it in index form. To write this in index form, we have 1 over 64 equals 0.5 raised to power x. And this is a decimal. We can write this decimal as 5 over 10 raised to power x. And this 5 over 10, we can cut it and break it further down into 1 over 2. So we have 1 over 64 equals 1 over 2 raised to power x. So we can write these two in index as well. So to take this to index, we have 64 raised to power minus 1, and this to index will give us 2 raised to power minus 1 multiplied by x, which is 2 raised to power minus x. We need to rewrite 64 in index so that it will be of the same power as this 2. So this will lead us to 2 raised to power. How many times are we going to multiply 2 to give us 64? That is 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, and 32 times 6 will give us 64. That is 2 in 6 places, which is minus 6 multiplied by minus 1, which is equals to 2 raised to power minus x. So, cutting the powers, we are left with minus 6 equals minus x, which is simply x equals to 6, taking away their negative part. Then the third question says, logarithm in base 0.1 of 10,000. So let's equate this to another alphabet as well. Let's take another y. So we are left with 10,000 equals to 0.1 raised to power y. So we can write this as well in decimal, in fraction rather. So this will give us 1 over 10 raised to power y. And this is another 10,000. So rewriting this in index will give us 10 raised to power 4, which is equal to 10 raised to power minus 1 times y. So we have 10 raised to power 4 equals 10 raised to power minus y. Taking away the 10, our final answer in this case will be minus y equals to 4, which can be written as 4 minus 4 equals to y. The fourth question says logarithm in base 625 of 0.2. Let's equate this one to another x. So rewriting the expression, we have 0.2 equals 625 raised to power x. And taking this one to its fraction, we have 2 over 10 equals 625 raised to power x. And breaking it further, we have 1 over 5, which is equal to 625 raised to power x. If we rewrite this in index, it is going to give us 5 raised to power minus 1. And this one in index 625 is the same thing as 5 raised to power 4 multiplied by the x that we have there. So the 5 cancel out, we have minus 1 equals to 4x. So we are dividing both sides by the coefficient of x, which is what? 4. So we have 4 and 4. So therefore our x is minus 1 over 4. So in order to move to the next question, question number 5. Question number 5 says logarithm in base 3 of 1 over 81 equals to, let's take y on this note. So we are writing this in index form, and it's going to be taking this one to index. From the beginning, we have 81 raised to power minus 1, and this one will give us 3 raised to power y. How many times are we going to write 3 to give us 81? And that is 3 raised to power 4 multiplied by minus 1, 3 raised to power minus 4 equals 3 raised to power y. And our final answer on this note will be y equals minus 4. Question number 6 says logarithm in base 4 root 2 of 512. Let's equate this to x. Firstly, we expand it by taking it to its index form, and that will give us square root of 512 equals 4 root 2 raised to power x as usual. Taking this one back to its original form. The original form means we are going to multiply this one by itself. That 4 will give us 16. 16 multiplied by 2 will give us 32. That is the original form of 4 root 2. So we have root 32 of x equating to root 512. Taking the square of both sides, in order to remove the square roots, we have the square of both sides. So this cancel out. We are left with 512 equals 32 raised to power x. Then we need to rewrite the two of them in their index form. And 512 is 2 raised to power 9, while 32 is 2 raised to power 5 multiplied by x. Taking away the base numbers, we are left with 9 equals to 5x. Dividing both sides by 5, we have x equals 9 over 5, or how many 5 can we get in 9? 1, remainder 4 over 5. On this note, we have come to the end of yet another edition of Brain Maths. Don't forget, to subscribe to this page, to this channel by clicking on the subscription, and also turn on the notification so that you'll be among the first to be notified when a new video is released. Until I come your way next time, I remain my humble self, Mr. Awena Suleiman Taiwo. Have a wonderful day.